Good morning, ladies and gentlemen. Welcome to the international webinar on transforming your business with AI and ML practical steps for data to deployment, organized by Science Plus in association with IRAJ webinars. On behalf of entire organizing committee, I am Swaleha Khan, organizing secretary, who would like to welcome you all for this webinar. Ladies and gentlemen, let me introduce our organization. The motto behind this non-profit association is to bridge the gap between students, professors, academics, and industrialists from multidiscipline. Apart from organizing various seminars, expert talks, and conferences, we have various highly rated multidisciplinary journals in the field of science, engineering, technology, and management. Since our inception, we have been arranged various international conferences at various parts of the world, like New York, London, Australia, Hong Kong, Dubai, Bangkok, Kuala Lumpur, India, etc. More than 1 lakh people across the globe are associates with us, and more than 5 lakh research papers have been presented and published during our journey. Today, I am glad to welcome you all as the member of this fastest growing network for the advancement of science and technology in terms of research and innovation. Today, we are very much fortunate to have eminent professor and expert who is joining this webinar as an expert speaker and guest. Session speaker, Dr. Madan Mohan Tito, Ayyalasomayajula, Senior Technology Architect, Doctorate in Computer Science, Aspen University, USA. Now, I would like to welcome our Dr. Madan Mohan Tito to deliver the webinar. Thank you.
So welcome everyone. Perfect. Thank you for letting me know. My name is Dr. Madan Mohan Tito, Ayyalasomayajula. Thank you for that amazing introduction as well. Exciting today to talk about the webinar on transforming your businesses with artificial intelligence and machine learning, practical steps from data to deployment. Let's begin. I'll share my screen for the presentation, and after that, we'll move on. Okay, so I hope you can see my screen.
Yes, sir.
Thank you. Okay, let's get into the discussion of this good webinar. And first of all, I Iraj also for setting this wonderful platform. So to discuss about our topic, let's get into the classification of the standard enterprises first. So I think most of you are aware of this classification, but for some of the candidates, whoever are not fully aware how generally the enterprises are considering the other enterprises in different classification, I'd like to introduce first, and then we'll move on. So if you look at the classification of the enterprises, there are generally at a very high level, there are 3 different enterprises categories. Like one is small enterprises, that is SMEs. The other one is medium enterprises, then the large enterprises, which are also like corporates. So the SMEs, if you consider, they are mainly like micro businesses or small businesses. Typically, they may have around 1 to 50 employee base, and then their revenue is up to around 10 million. Then let's take the example of medium enterprises. They generally typically have around 51 to 250 employee base, and then annual revenue can go anywhere between 10 million to 50 million. Then coming to the large enterprises, anything beyond 251 plus, and then over 50 million revenue generation and all. And to be very honest, this is not any standardized one, but this is a default or de facto standard, which is something like an unsung story considered by other organizations. There is no set of standards already established, like definitely it is like this. Okay. And then coming to the other part, there are multiple other subcategories also you can consider as part of this, something like startups, unicorns, blue chip, MNCs, and Fortune 500. So for unicorns, mainly if, whenever the system is getting into the place, if the uh, if the organization is coming up and it is valued at over 1 billion and above, yes, I know it is generally considered as a one kind of thing. Otherwise, related to the blue chips and all, they are generally the organizations where they are all well established and they are financially sound. And in terms of MNCs, you might be well, like, the companies where they are working from multiple geolocations, so they are all considered as MNCs, so something like Infosys or TCS or Wipro. All these service-based companies, they have their MNC presence. And then Fortune 500 companies, US largest 500 companies. So for example, something like Tito Motors or Amazon, all these big companies, they have that footprint in that list. So let's get into the second level discussion after this. So if you look at these typical organizations, what is the application count that we can expect? So in SMEs, typically you can have around 10 to 50 or anything range between 10 to 50 different unique applications. And with respect to medium-sized enterprises, you can see 50 to 100 distinct or unique applications. And then with regards to the large enterprises or corporates, 100 plus. So if you ask me, with my personal experience in large corporates, it can start anywhere from 700 above. Okay, 700. The largest one, whichever one I have worked on, is nearing to 12,000. But at the time when I worked, it is 9,500 odd. Okay, so it is very high. It's not small in number. So now you can you can understand the scale of this presence, something like the application presence, how far it could be, and then how much it could be and all. So now let me take you to different perspective, like what are all the common AI applications in these enterprises. So I'm trying to list down few different categories where these are all like some set of common applications among largest corporates or even for the small SMEs or medium-sized or mid-sized enterprises. So first and foremost, I think this is a common category among all the categories, that is customer service based applications. So you can have something like chatbots and virtual assistants, and then sentiment analysis based systems. So these are very, very common applications. And then coming to the marketing and sales, wherever any product sales or any planning or any service-based systems are there, generally they do have their marketing and sales teams, and then they look for different AI-based applications also. So even though they might be having their own existing applications, so they still look for these kind of AI capabilities. So you can have the different application sets from AI, something like predictive analytics. So earlier you might be having something like a descriptive analytics kind of thing or business intelligence kind of applications. But now with the support of AI, you may move towards the predictive analytics, and then you have personalized applications. So in the sense, like whenever a person or a customer is or a subscriber is trying to reach the normal representative, then they may, or even the standard applications, they may actually present a standard offer. or a standard plan to the customer. But with the personalized one, when actually the customer is trying to reach out to the customer care representative or to the marketing or sales representative, then still to improve the quality of service, they can offer more personalized ones. So that is another aspect of it. So this is a bit of advanced one. And then uh, coming to the other area or the functioning part of the enterprise, that is supply chain, where demand and supply related activities are involved, you have the important applications like demand and forecasting. So a lot of AI related applications or features can be introduced into that. Then the most important and very complex thing that you can see is route optimization. So big organizations, something like Walmart or Amazon, when these companies are trying to offer their services to the end user, they may have to deliver the items to the end users, and also they have to work with the route optimization. So in an effective way, in a cost effective way, the items must be delivered. So route optimization plays a vital role in that. And of course, this is the trickiest thing as well. It is not that easy. Okay. And then coming to the uh, fourth criteria in this particular one is like finance. So finance could be by itself, it could be a sector, or finance could be a department that is present in the organization. So in both scenarios, generally the fraud detection based applications and then automated financial analytics, both of them are going to play a vital role to build the AI based applications. Fraud detection, which do not think that only, whenever you are performing a bank transaction, then only the fraud detection can play a role. It's not only that, even the influx of funds and then the outgoing of the funds, whenever they are trying to see a mismatch and all, even those scenarios they can consider for the fraud detection. And coming to the HR, I think most of us are very much aware of this particular functionality. HR is very well, known to every organization as well as even to us. So we have a lot of functions in this. We can introduce a lot of common applications, something like talent management, employee engagement, just to give you another set of applications that you can have in this criteria is something most of you are aware. Like a lot of attritions are going on in a lot of companies, right? So maybe you may always hear something like, hey, 13% attrition rate is there, or 15% attrition rate and all. So to predict that, or you can say something like, what is the churn rate prediction and all, you can introduce your churn prediction systems where you can even equally count the attrition rates and all. So that churn prediction kind of thing, it is not just confined or just limited to HR related criteria or category. So if you look at the telecom subscribers, or maybe if you look at any system where they are trying to provide a subscription based models, like maybe Google, in terms of their YouTube system, or maybe Amazon or Netflix, all these guys, they try to understand, what is their churn prediction rate. So how many subscribers may get into the system, or mainly how many subscribers may leave their network in a specific time. So they can predict that. So this is very important application. So it is just not limited to one specific area like HR. The churn prediction is very important one. And I would like to give you one more example in HR nowadays, what's really going on. So if any job is required to be placed, or if any candidate is expected to be onboarded, generally to onboard a candidate from the job description to the final onboarding date or reporting date, it used to take around 120 days on an average. Okay, but now with the help of AI-based applications, they are trying to cut it down almost to 70 to 75 days, or in some cases it is much lesser also. So people are trying to scan the resumes, and then they try to find out the similarity scores. And then if the similarity score is there or it is more than 80% compared with the job description and the keywords given in a job, and then the resume related keywords, so then they do the matching. Once the similarity score is pretty high, then 80% or 85%, then the candidate is shortlisted and then the interview process will go. So instead of manually looking at each and every resume, people are trying to introduce these kind of AI-based systems. So this is one good application in HR area. And then you have operations and process automation. RPA is one which is getting a lot of traction. Of course, you can have some kind of what you call pushback, saying that RPA might not be completely AI, but it is also a part, or I should say, partially it is AI. And along with the bots, they are trying to introduce a lot of AI-based functionalities behind the scenes. So this one also is trying to play a vital role, the process management. And then you can see the most important attractive element is like predictive maintenance. So in all manufacturing industries and all, you see this predictive maintenance related application, which is going to predict when exactly a particular part can come, or just in time related inventory related issues, all that you can see. Okay. And then with regards to healthcare, you have the medical diagnosis and then patient management related systems. And most of the time, which is not sung by anyone, or most of the times it is taken a bit of a deprioritized version is legal and compliance. But it is very important in large organizations like large corporates and all. So the first one is document review. To give you an example in this, say for example, a claim related issue is coming or a legal issue is coming out. So at that point of time, there are a lot of documents that must be analyzed, or we should get a summary of it, and then we have to see what exactly the claim is for, and then we have to match it, and the key points must be written down, and we have to give the right answer accordingly to the end user or the person whoever is trying to give the claim and all. Okay, so a lot of things are present in that. So for this, generally in the organization, what's going on is maybe the legal team, paralegal team, and then the support team. All these teams are trying to work together to finally generate the output for end user. Okay, so it is a time-consuming activity and a tedious job. So to do this one, generally now we are going with the NLP-based and LLM-based systems. So document review is trying to play a vital role where AI-related capabilities can be introduced, and then as an organization, you can serve better. And the other one is regulatory compliance. So regulatory compliance, it is very important. Say, for example, you are trying to deal with HIPAA or CCPA or CPA or CDA. So these kind of different regulatory compliances, if as an organization you would like to address, then this is very important to have the AI-based applications where you can identify certain key non-compliance issues, and then you can present it. Or the score you can generate, hey, in this area, my score with regards to regulatory compliance is less than 70%. I have to take an immediate action, something like that. Okay, so this is another set of area, or I should say another set of applications related area where you can concentrate or focus on. Now let's get into the challenges or the initial challenges as an organization that you may face. So one thing I can say, you may even see the similar challenges in such a way that even in the past, other organizations have already seen. And as an organization, if you are trying to start your journey, you may see that when you try to work on new applications in your organization. So at that point of time also, you may see some of the challenges. So let us try to analyze those key challenges. So the first and foremost thing is data quality. So data quality is the biggest challenge. So having the clean data set is very important, and generally we'll get all the all the data sets, or maybe one data set or multiple data sets, or whichever is coming out from either single source or multiple sources. You may see generally very poor data quality kind of data sets. Okay, so you have to do a lot of work, and then you have to get it right, and then you can make use of it for the artificial intelligence related models and all. Then the other one is infrastructure and scalability. It is another big hurdle, as you may have to deal with larger amounts of data sets, and the volume at which, or at the rate of data at which you are getting is very high, maybe. Okay, then you may even equally face the skill gaps. The required skills might not be there with the people, so you may have to look at that. Then the other most important critical issue is you might be already dealing with a huge number of legacy systems. So imagine something like you might be having around 9,000 applications, and then maybe out of it your legacy applications where they're deployed at least a decade ago, and then you have to work with that where their entire system is totally different. Maybe they might be working on mainframes or AS400, or maybe a COBOL based system, or very old one like Visual Fox Pro. Those kind of systems you might be having, and then still they're running in the enterprise ecosystem, and then you have to deal with it and then integrate it. It's a tough thing. Okay, and then you have high costs associated with AI related applications, where whenever you are trying to use the big data as part of it. And then you have the other issues like interpreting results. So this is one of the key issues. So from the developer perspective, you might be thinking about, oh, I'm trying to present my output, and then my output is holding something like F1 score. But do you believe that it is very well understood by the business analyst or the end user or the client, where they just deal with the business function? So that interpretation is not easy. So there should be a bridge between the outputs, whatever as an AI system your system is trying to provide, versus the business functionality. That is another thing. And then regulatory compliance related challenges are very key. Maybe if you know about HIPAA related things and CCPA, CPA, CDA, all those criterias or regulatory compliances, you can understand what is the complexity involved in that. And then uh, the other one is like storing the data in silos, where the data is not available in a single location, or maybe even though it is something like a distributed one, it is not up to the mark and all. So those kind of challenges you might see, and then there are many other challenges you can see. But these are the critical challenges that generally we may face. Now, coming to the AI model building process across organizations. This is most of the time a common pattern or a paradigm that we see among enterprises. So the first one, I can say that this is around, or this is like a 5-phase approach or 5-stage approach. So in stage 1, you should have your data sources ready. So the data sources could be from either your SQL-based systems, or it could be from your document-based systems, or it could be from a simple, JSON kind of file system, or a CSV-based, or it could be your S3 bucket, or it could be on your Amazon blob, or even if you look at the bottom, it could be even from your IoT devices. So you get your data from these different or unique systems from your organization, and then this data is then then it will undergo the ETL or ELT process. So ETL or ELT is basically, it stands for extraction, transformation, and loading related thing. You can go through what exactly it is a little later, but I think most of you are aware. And the final outcome of it is to have the data in a right way. That means ensuring the data quality for that. Once you have prepared the quality data in your ecosystem, then that data will be given to the next level. So many guys or many upcoming developers and all, they may feel like, oh, I have the AI model, so that's it. There is no need to do any extra activity if I have the data. No, there is an intermediate step that we generally call it as the pre-processing. So as part of the pre-processing, you may do a lot of work. So if it is a predictive model, you may just do some cleaning, integration, then the feature selection, feature engineering, or splitting the data. You may look for the outliers, all those things you may do. But if it is something like a text-based analysis where your text analysis or NLP related things are involved, maybe you may use the text cleaning, tokenization, lemmatization, or text normalization, all that you may do. Then if you are trying to deal with the images as part of your AI related application, you may do some pre-processing activity, something like image resizing, image segmentation, image denoising, image augmentation. So certain techniques are there as part of the pre-processing. So these techniques you have to adopt, and then you will get the right data set for AI model to use it. Okay, then once this pre-processing stage is over, then the true AI or ML or deep learning or NLP related one, or maybe you can call it as a computer vision based, all those techniques will come into picture. And then you have different techniques, like either you may build the predictive models or prescriptive analytics or classification or regression or clustering, anomaly detection, or you may go with generative models, or you may go with the large language models or sentiment analysis, machine translation. So named entity recognition, any of these things you generally go with. You may have a different other technique as well, which I might have not introduced here, but these are all the common models that generally you may use to build your application. So at the end, as an application will try to consume the data that is produced by the AI and ML. Okay, so this is the general flow. So you may ask me like where my training and the model building stages will go. So even that is also something like when you are trying to split your internal data into a certain ratio, something like 80-20 or 30-70 and all. That is also a pre-processing step. Now, let me take you in organizations how AI related applications or services are actually plugged in. So I'm trying to present here around 4 different models where you can see almost other models, whichever one you may see could be an extension to this. So let's try to see the first model, that is extended AI application or service that is actually utilizing a single source. That means you might be having your existing application here. Existing application is trying to generate the data and it is getting stored in a specific data store. And then you would like to provide or present a new AI-based service or an application. So a new application is totally presented or introduced, and then it is just trying to consume the data from this data store, and then this is not going to intervene in this particular process or application. So this works just like an extended version. So this is going to work totally in an independent way. That is that is one good thing. And then the second model is something like an embedded AI application or service that is coming out from a single source. So in this context, the AI related service would be working along with the existing application. So an existing application must adopt a few changes to accept this AI service. Within the application itself, this AI will be there. So this AI service along with the application is trying to consume the data that is generated by the application or maybe generated by some other applications. And then this one, it will try to provide the functionality, the required or desired functionality. Coming to the model 3, you might be dealing with multiple applications like application 1 to n, where each and every application is trying to generate the data into different data sources, and as an extended system, your AI may come into picture, okay, or your AI related service is plugged. And then coming to model 4, it is just an embedded AI service. It is not an extended one, and which is dealing with multiple applications. So whichever model you generally consider or an extended versions to this could be coming under either of these 4 generally, which could be a complete extension to it. So now coming to the implementation aspect as a service provider or a partner to the organization, if you would like to provide the solution, or even as part of the organization, you would like to provide the implementation. What are the different implementation approaches that you can provide is listed down over here. So your application could be implemented either as an in-house related service, or it could be coming out from a COTS-based application, or it could be even equally done through AI as a service. So the same is equally applicable for the embedded AI service models. Okay, this one is the extended one, and this one is the in-house, embedded version. Then coming to the placement of those systems, if it is in-house or COTS or AI as a service, how your implementation is done. So in-house related implementations are generally confined to a specific building or maybe to a specific hub, something like that. And then maybe you can place your solution in a data center. Or if you would like to have the solution on cloud, generally it can go to a cloud. So it is placed in a public cloud kind of thing, and then the solution will go. And then for the COTS based also, it is similar. You can have it in the on-premise or a cloud-based solution. And then for AI as a service, generally it is either a public cloud or a private cloud. The same thing is applicable here for the embedded version. So now I would like to ask one quick question to the audience. So in what context we go with in-house extended implementation model? So anyone would like to answer these questions? Like in what context we select in-house embedded implementation model? What is the ideal scenario to work with extended or embedded AI as a service model? So friends, you're open to answer. You can unmute your microphone, and then you can present your solution. No response? Okay. Okay, friends, let me give you some answer for this. So in-house extended implementation is very, I should say, whenever you have some legacy application on top of it, you would like to place the solution where you would like to consume the data, and then you would like to go with the AI-based service or application, then this kind of model is more appropriate. Okay. Then the other one is like in-house embedded implementation is something like this. You have some critical application where it should not go out of your boundaries because of the data restrictions, or maybe it could be because of something like a trade secret. So whenever you are dealing with that, in those kind of scenarios, you are not allowed to, place your solution in either COTS based or maybe something like AI as a service. So in that kind of situation, you just try to, embed the AI related functionality in the existing one. And along with that, in certain contexts, the application, whatever is there, until and unless you add that specific feature, the application cannot be enhanced, okay, for the desired requirement. So for that kind of context, you can go with that. Okay, let's try to see how many different ways generally you try to build the learning platforms. Learning platform in the sense like AI-based learning platform here. So here I'm trying to present the centralized learning platform. So how it may look like. So here you have your data sources. You are having your ETL or ELT preprocessing, and then you have the centralized data sets, and you have your AI related model building. So here there is training process, and then after that you try to go with the building of global model. So once the model is present, that model can be consumed by the relevant applications. So it could be a chatbot or a sentiment analysis or demand forecasting, or it could be a route optimization or a document review, whichever one it is. So all of them are trying to make use of this global model. So this is how organizations are going with the centralized learning platforms. Now, I'd like to post a question, another question. At least I expect some response this time. Can we have distributed datasets as an input to train and test our AI models while implementing centralized AI platforms? Anyone would like to answer this? You have a couple of scenarios in this, like distributed datasets are co-located and distributed datasets are present at different locations. What do I mean by that? So here, this is if you look at this, this is like a centralized, this is like a centralized data set. So can it be distributed where this AI related model building is happening in a specific location, where your compute and data store, everything that is related to the AI is present in one location? Any answers? Okay, so the simple answer is yes, you can have. And coming to the centralized AI platforms, their benefits, you have many benefits that you can see, something like unified infrastructure. So you can use always the standardized infrastructure with respect to your compute, with respect to your storage, or with respect to your tools, libraries, everything. So standardization and consistency. As I said, you can make use of the standard library set, tools, everything. You can ensure a standard is well established for that. And then the other one is like robust security, centralized governance, economies of scale. All these ones you can achieve. And okay, I'm explaining about only benefits. So are there any challenges or disadvantages with this system? Of course, yes. No system is free from disadvantages generally. So based on the context, we may have to use. Coming to this disadvantage set, you have something like data privacy concerns, because the data is at a centralized location and the compute, everything, the model building, everything is going to happen at a centralized location. You generally get into the data privacy concerns, especially that are raised by the regulatory compliance related systems or regulatory compliance related points. Then the other one is network latency issues. So because the systems are very well located at a single place or in a centralized location, you may have to transfer the data. So you may incur the latency issues, and then you have single point of failures and then high initial cost. All these ones you can see in this regard. Now coming to the other other learning model, you can see that as distributed learning model. This is little different than the previous one. So your stage one, that is data sources, is not going to change, or your ETL or ELT process also might not be changing. But with respect to the data sources, the data sets that are used by AI, ML, or deep learning or LLMs, all those ones, it could be placed or located in multiple locations. And then coming to your the major difference is in this stage 4. That is, your training and the global model building is going to happen with set of distinct nodes where their nodes are actually demarked or classified into coordinators and workers. So these coordinators, they try to coordinate, and then they provide the job to these workers, and then the work is done, or the AI model building is done at different worker nodes, and finally the models are consolidated with the coordinators and the final global model is generated. That is how it can work. And then this model is consumed by the applications. So this is how it works. Now let's get into the benefits. So you have good number of benefits with this kind of model. You have scalability, fault tolerance in the sense like, in the centralized version, if one node is down or that entire location is down, you are not in a position. I should not say entire location. If one node is down, maybe you may have some single point of failure related issue. But in this context, even though one node is down, your system is not going to be impacted, and you have always the fault tolerance capabilities because of multiple node involvement. And then the resource utilization, performance, flexibility, cost efficiency, all these are going to be very beneficial for the organization when you consider this kind of learning platform. Now, you may ask me, are there any challenges? Of course, this one also, it comes with certain number of challenges. The complexity is very high to build any AI-based model using this distributed learning platform AI technique. It is going to be very tedious, complex in nature also. And then the data transfer cost, this one is not excluded. It is almost similar to your centralized systems. Then latency, it is definitely a little bit high because inter-process communication between multiple nodes are also involved. So this one also can increase the additional latency in your system. Then the other one is security, because multiple nodes are there, automatically your security team will come and say that, hey, a lot of things are required to be considered. And regulatory and compliance related challenges, this is also a bit complex in nature to handle, and synchronization. So in this context, you may have to do a lot of aggregations and all from the distributed sources and all. So the complexity for data synchronization and model synchronizations, all that will add some additional challenge. Then you may ask, like, okay, is there anything that I can go with a local based learning? Of course, yes, that one we can call it as a federated learning platform. So in this model, your ETL or ELD process is done locally, and your learning, that means the training and the model building, is going to happen at one specific location geographically. And then, so if you look at, this is done at location 1, for example, this is location 2, and then this is location 3. So once the model is built locally, that model is actually aggregated at a centralized location, and then maybe we can call them as either coordinators or aggregators. And then that model is again, once the model is built, that is again synchronized locally. So there is a bidirectional communication between the local learning models and then the aggregations, but there are certain advantages in this. And then the applications are going to consume the model from this global model. Then coming to the advantages, data privacy and security. You will not get into the data privacy and security if your data is with some sensitive data sets and all data points. You don't need to actually transfer it to the central location. See, I understand something like this. In certain areas or in certain countries, you have certain restrictions, like if your data is going out of your country, it is something like a legal issue. So certain data points or data sets should not cross the boundaries of your nation. So the location of your data is very important. So that's the reason most of the time you might be undergoing something like, hey, is your data located in US, or is your data located in Canada, or is it in India? Something like that. So always whenever you are trying to fill out the RFP, you may see those kind of questions. Okay. And then you can definitely see the other advantage like reduce latency, because you are not trying to transfer the data, you are trying to transfer the models only. And then the scalability related thing, of course, it is very highly scalable. And then resource efficiency, you can see that one. And regulatory compliance also, as I said, because your data is not actually moving out of your country or your specific working zone, you can actually fall into the compliance quickly. Then other challenges with regards to federated AI platforms, this is also complex in model management, because your models are placed at different locations, and then you have the aggregators also. So this is very complex in nature. Then the other one is heterogeneity of devices. So in one location, you might be working with one type of configuration for model building, and the computation, whatever you have used, maybe you can say, hey, I was using Geon related models where my CPU is just only with the 4 sockets, and then it is with the deca core kind of thing, like that. And then you might be using just a 256 GB RAM kind of environment. But in another location, maybe it is way too high. Maybe you might be going with multiple sockets, maybe 8 sockets each with around hexa-core kind of thing. It is totally different. So that kind of distinction you may get into. So you can see a difference in model building times also, and that equally translates to your response times. The other one is like data quality and bias. So at a different location you are doing, maybe your governance is not up to the mark. So you will definitely enter into certain situations like poor data quality, and there is a bias introduced into the data. Then the other one is like limited computational power or communication overhead, all these ones, because you are supposed to connect with aggregators and the local models. There could be additional communication overhead. So you may ask now, oh, we have already talked about 3 different models. What are that actually used by the organizations? So to answer that in a simple nutshell, I should say we are using integrated AI platform, because each and every AI-based platform that is either centralized or distributed or federated, they bring their own challenges and advantages. So we go with the integrated AI platform such that whichever one is important based on the context, we just use it. Okay. So it brings the unified strengths, it improves the performance, and then innovation and compliance, everything it can be done. Then you may ask, like, is there any, strategy that we can use, or strategies that we can use as businesses to manage the costs associated with the implementation of these new AI services and all. So I'm trying to present some strategies. The first one is like small, start small. So you don't need to implement your AI-based systems all at once. You can begin with few incidents, or I should say few instances of your AI-based services or applications, and then once you understand how they are functioning in your system, you can actually take it forward at a larger level. Then leverage cloud-based AI services. For example, I'm not promoting Azure here, but I'm working on AI-based systems in Azure and other systems most of the time, especially with Azure kind of environment. I just presented here. The one is like, Azure Cognitive Services. You can see a lot of services under that. And then Azure Machine Learning, Azure Bot Framework, Azure Applied AI Services, all these ones you can actually make use of it, and then you can quickly build your prototype, and then you can do proof of concept or proof of technology related activities, and then you can move on. Then the other one is like optimizing data management that you have to look at. That one, in that way, a lot of work will be reduced, and because you have the clean data set, lot of advantages you can get with respect to your AI model, and it can improve the accuracy. Otherwise, you may feel like, oh, initially I'm getting around only 40% accuracy. But once you clean the data, you do every single bit of piece with respect to data quality and the filtration things, then you may get into a situation like in a first shot itself around 75% accuracy. And after that, if you try to tune your models more and more, you may get up to 90, 95 and more. So you can have something like some pre-trained models also to reduce your time to launch your AI-based service or application. The other most important thing is use of synthetic data. The teams, whoever is trying to make use of these AI-based models, or whoever is trying to build the AI-based models, especially in some critical areas like healthcare. So you may take longer durations to get your approvals. So for that, my suggestion is go with some synthetic data, prepare the model, and meanwhile you get the approvals, and then you can replace it with your real data, and then you can see the accuracy. In that way, at least your development time or the challenges, whatever you may face with respect to your standard development process, you can reduce. And the other one is invest time in training the employees. And to go with this kind of AI-based ones, my suggestion or recommendation is to consider the high impact use cases, not like a small use case and where the organization might not be in a position to see the impact. At least you have to consider a couple of cases to start your AI-based journey and to promote AI or ML in your system. In that way, the digital transformation with respect to AI can be enhanced in the organization quickly. Then there are other ethical implications you generally see or observe when you are trying to build the applications in terms of AI. So the first one is AI bias, algorithmic bias. So no AI system is free from the algorithmic bias. So you have to be very careful about it. So you have to think about for whom we are trying to get the data, what type of attributes are there, and then from which location it is coming out. All that you have to see, and then you have to analyze carefully, and you may have to thoroughly revisit your models to understand is there any algorithmic bias or not. Then you have to think about the privacy and surveillance, and then transparency and accountability. So those aspects are always there. Then coming to the AI-based principles and frameworks for ethical considerations, you have different ones, but I strongly suggest to definitely look at this European Commission's ethics guidelines for trustworthy AI. Okay, this one is pretty recent, but it has a good number of points to consider for the organizations. But along with that, you have the other frameworks like Google AI principles, Microsoft responsible AI principles, like that. Even IEEE is also providing, but my recommendation is to definitely visit this European Commission's ethics guidelines. Now, coming to the enterprise architecture, how it may look like in the entire ecosystem. Whatever we spoke till now, the visualization of it, how it may look like. So in the enterprise architecture, I try to present it in a way like you can understand. Say, as an enterprise, you are dealing with multiple hubs. Hub 1, Hub 2, Hub 3. Maybe Hub 1 is located in New York, Hub 2 is located at Pennsylvania, or Hub 3 is located at maybe in Mumbai. Hub 3 or Hub 4 is located at UK, London, something like that. So where your company is operating from distinct and different geographical locations. So in that, you can see each and every hub is composed or consisting of different things, like they can have their cloud presence as well as on-premise presence. So in terms of on-premise, they can have multiple data centers, data center 1, data center 2, data center N, something like that. Sorry, there is a small typo here. But with regards to Azure or maybe any cloud platform, you can have your application base in different regions, like region 1, 2, 3, up to N. Maybe it could be something like US East or US South or Central South, maybe West, US West, something like that you can have. And you can have your cloud presence as part of your organization. Either it is on Azure or it could be AWS or GCP, or sometimes it could be on a private cloud also. So all these are possible, and the overall stack may look like this in terms of cloud, like infrastructure as a service, platform as a service, containers as a service, functions as a service. On top of it, again, you can have your AI frameworks, services, and tools, and finally the applications, which are the consumers. Okay, the similar stack is also present in your on-premise environment. So networking, your storage, then compute, then the middleware, and your AI frameworks and services and tools, and finally your applications. So the similar type of arrangement can be repeated across multiple hubs. So this is at hub 1, and this is at maybe hub 2 or hub 3 or hub 4, like that. So in this way, the entire ecosystem is generally built, and then the communication is established across different hubs. Now, you may think about, okay, these are all there. What could be the future? What kind of different requirements that enterprises may see as their future requirement? So in the initial stage, you may deal with just simple model building and then building some applications that consume the artificial intelligence related models. That could be either given by your ML, machine learning based model system, or it should be from a deep learning based one, or it could be NLP related one and all. But at one point of time in the future, what you may see is something like, hey, I have built my model on certain ecosystem, and then I would like to port it to a different ecosystem, so or different environment. So what can I do for that? So those kind of things will come into your mind, and then that could be the additional requirement once you actually progress forward with the multiple AI-based models and systems. Okay, so for that, there are a couple of options that are coming up. They are not fully mature, but at least one is, I can say, more than partially mature. The other one is, just in the incubation phase. The first one is ONNX, that is Open Neural Network Exchange. It is an open standard for machine learning interoperability. Then the other one is NNEF, that is Neural Network Exchange Format. So it is mainly for the artificial neural network data exchange formats. So both of them are having their own advantages and disadvantages. So you can have a look at it that. Okay, then the other one on the right hand side, you can see OpenVINO. This one is also actually trying to provide the acceleration for your models, what you have built on different environments. So you can see here, like OpenVINO is something like an open source toolkit designed to streamline the deployment and optimization of DL models, basically. Even though it is meant for DL, still it can work for some of the ML based ones also across diversified hardware platforms. So that is the other one. So you can see here something like you might have written something using your PyTorch or TensorFlow or some other techniques. Even it could be the model is on ONX based format. So you can use OpenVINO, then it will try to optimize the performance on these different platforms. So basically the hardware and the operating system it will look at, and then it will try to improve the performance of your model according to the underlying platform. That is one beauty of this. There are advantages and disadvantages, or I can say the comparison between Onyx and an EF. So there are many things. Maybe you can just go through whenever you get some time. So as I said, Onyx is a little bit more matured platform than NNEF. But apart from that, if you consider something like adaptability, I can say ONNX is widely adopted compared to NNEF. And the file formats, you can see something like binary and text-based formats. And here it is like text-based format that can be used. Yeah. So with this, I'm trying to conclude my my presentation or session. And thank you very much, Iraz and the team, for giving such a wonderful opportunity. And then before totally winding up, I would like to open the session, open the floor for any questions. So team, yeah, the floor is open for you. If you have any questions, please do let me know. The floor is open for you. If you have any questions, please do let me know. Audience are very quiet. Are there any other questions? Or shall I wind up? Saleha, do you need to open the microphone for others, or is it?
No, sir. I was just about to end the meeting.
Okay.
Okay, so thank you, Professor, for sharing your valuable time and for joining this webinar. On behalf of the organizing committee, Science Plus Conferences and IRS webinars, now I would like to thank all the sponsors and coordinators. I would also like to thank our president. We will happy to hear your comments and compliments or suggestions at our Facebook and Twitter page. This video will be available shortly in our YouTube channel. Kindly subscribe our official YouTube channel, IRS Conferences and Seminars, for all past and upcoming webinars and expert lectures. Thank you all. See you soon in another webinar. Thank you, sir.
Thank you.